Hi, welcome back and congrats on completing chapter 3 of our CMG-MathSpace AKI-OLA math series. This episode marks the beginning of chapter 4, that is Surds. Now you may have wondered, why Surds and what's its essence? It is one of the key concepts I missed in senior high. No, I'm not saying I didn't do well, but I realized I did more of a rote learning, and that was very cumbersome. So, in this episode, like we do every topic, we do introduction, giving you the concept, the idea, the essence, why that topic. From there, we zoom into the calculation. So the main idea is for you to get a concept. This is very, very important. This is one of the key things we missed in senior high school. Right, so now surds come into play when we encounter numbers that can't be neatly expressed as fractions or decimals that terminate or repeat. So you recall that we did a real number system where we did natural numbers, the whole numbers, rational numbers, and irrational numbers. So our focus in this particular topic is on irrational numbers. For rational numbers, we said that they are numbers that can be expressed as a common fraction, or in fact fractions, either decimal fractions or common fractions. Now for the irrational ones, they are those that we can't express them as fractions, common or decimal, right? So this is the main idea. Right now we are saying that these are irrational numbers. We mean surds are irrational numbers. So we are going to deal with irrational numbers under what a topic called surds. Now, so these are irrational numbers like the square root of 2 or the square root of 3. Right? You remember what we said about rational numbers and irrational numbers. Now, that never settle in exact fractions. So the numbers that we can't express them exactly as fractions are what? Irrational numbers. Now, surds allow us to keep these numbers exact rather than rounding them off. So in surds, what our main focus is to avoid rounding numbers, avoid fractions, either common fractions or decimal fractions, and we are avoiding rounding off. So what it means is that our target is that we still want exact numbers or the precision in our calculations. We will tell you why we need exact numbers in whatever calculation that we do. Now, this is crucial in geometry, engineering, and calculations where precision matters. You are getting the idea now. So in geometry, in engineering, and other calculations, this is what we need. We need precision. Hence, we stick to what? Surds, right? In the exact number. Now, surds help us handle roots, exactly bridging the gap between rational and irrational numbers, right? So what the irrational numbers are going to do, which we are going to avoid, the fractions and all that. We don't want the fractions. We want the exact numbers. We don't want to lose any part of the number. So that's the essence of what surds. So in short, surds help us work with real-world values that can't be expressed neatly or exactly any other way, right? They can't be expressed exactly any other way. So we want the exact number. So making sure we never lose accuracy in the process. So that's the whole idea of what surds. Now we'll put them into practice and then tell you why we are talking about this. So sometimes, like I'm doing this because many a time you do these things, we learn in class, in the SHS class, we learn the process, how these calculations are done, without actually understanding why, the reason why these are done, or even the proof, how to even maneuver your way to this particular point. So at CMG-MathSpace, my main focus or concern or objective is to make you appreciate the course. Because I know a lot of people, at the mention of math, they become discouraged and alarmed. That is not my focus. I'm sure I'm here to make sure that you appreciate the course, you love it, right? And then even anytime you are even called upon to tell us about your favorite subject or course, you can tell us this is math. So from math, you can do engineering and then geometry. So that's what we are talking about. That's what is my concern now. Now let's go into the book and then read what is there. So here, I may not even bother myself talking too much because I have given you the overview of the course. So we are saying that at the end of this unit, the students should be able to simplify surds, carry out operations involving surds, rationalize a surd with monomial denominator. So by definition, we say when we cannot simplify a number to remove a square root, then it is a surd. Taking only the positive square root, positive and numbers, yes. So we have square root of 9, 25, square root of 81, and these are what rational numbers, because we can simplify this to get whole numbers, and these are not fractions, right? Just whole numbers, or yes, they are exact. This is what, and that's not our focus. Now, to give exact values 3, 5, 9, respectively, called rational numbers. Now, however, square root of 2 will give us 1.414. So this is what we are avoiding. This particular thing is what we are avoiding, right? We don't want fractions. We don't want decimals. We want the exact number. That is what it means. Because if you put this into calculator, square root of 2, we are going to get 1.414, and this is non-terminating. It's going to continue, non-recurring, and that is what we are trying to avoid. If you learned with us on chapter 3 on real numbers, this is what we were dealing with, right? Talking about the rational numbers. It can be expressed as decimals, common fractions, and they are terminating. You see, so they go on, right, and they have exact points. But these particular ones, we will do them forever, and we don't even know where to end. And that is what we want to avoid in real world calculations. That is what we are doing. So now when it could go to the square root of 3 also, we are going to get 1.732, and it's going to continue, non-recurring, non-terminating. If you like, punch this into your calculator. Square root of 5 is going to continue that way, so etc. Now, cannot be obtained exactly. And the roots are said to be what? Give irrational numbers, right? Exactly called the surds. So that is the point. Now, a surd is a square root which cannot be reduced to a whole number. So it's a square root. A surd itself. Now coming back to the main topic, surd is a square root of a number, right, which cannot be reduced to to a whole number. A whole number, we said, the integers, the whole the integers, or the positive and then negative whole numbers. That's what we call we say what whole numbers. Now, therefore, a surd can only be expressed exactly using the square root sign. So we want exact value. So we keep it, hence we have to keep it in the square root of that. So if a calculation requires an exact answer, irrational numbers must be left in the surd form. That is it. Now, other examples of surds, we have square roots of 7, square root of 11. Yes. So it means that these numbers are what? Prime numbers. And what do we say about prime numbers? Prime numbers are a number, or is a number that has only two factors, 1 and itself. So surds main point or major calculation or every objective is around these numbers. So a number with which is what? A prime factor, a prime number actually. So a prime number has only two factors, 1 and itself. So that is the whole thing. So going forward, we will introduce you to the properties of surds, and then we zoom into the calculations, right? So we will see you soon. Bye, like, share, and then we will see you on the other side. Bye for now.